Question 12 says, find the maximum length of water column which a capillary glass tube open at both ends of radius 10 to the power minus 4 cm can hold without leaking, given surface tension of water is 10 to the power minus 3 Newton per meter. Okay, obviously the question is from surface tension, and the situation is something like this. There is this tube, and the meniscus will be of this shape. This is the length of the water column. We can consider the angle of contact to be 0. We know that the value is very small for glass water interface, and here is air, here is also air. So the force due to surface tension will be at two interfaces, one here and one here. So the force due to surface tension is, and at this point, force is T into 2 pi r. R is the radius of the tube, which is also equal to the radius of meniscus. T is the surface tension, and since there are two interfaces, so multiplied by 2. And this is the force which is supporting the weight of the liquid, and so that is equal to pi r square h into rho into g. Now this, let's simplify this to get the expression for h first. The value of h will be then 4E divided by rho gr. Let's now put the values. It is 4 into 10 to the power minus 3. Rho is 10 to the power 3. In SI units, we know that the density of water. G is 10. This is 10 to the power 4. And the value of R has been given, and it is 10 to the power minus 4 centimeter. That means it is 10 to the power minus 6 meter. So this value is in meter. And on simplification, this is 0.4 meter, which clearly is 40 centimeter. If you look at the options, it is matching with option A. So option A is correct. Let's move on to the next question now. Question 13 says, distance between centers of two fixed spherical objects of mass 1 kg and 16 kg is 10 meter, and their radii are 1 meter and 2 meter respectively. A body, point object of mass half kg, is fired from the surface of the larger object towards the center of the smaller object. The minimum kinetic energy of the body to reach the surface of the smaller object is, consider their mutual gravitational force only. Then the four options are given. Obviously the question is from the topic gravitation, and the concepts of field and gravitational potential energy will be required to solve this question. So first of all, we just draw a schematic diagram. We have one spherical object, let's say here. Its radius is 1 meter. Another one is here of radius 2 meter. Its mass is 1 kg. This mass is given as 16 kg. And the center to center distance has been given as 10 meter. The radius here is R1, and that is 1 meter. The radius of the other one is given as 2 meter. So R2 is given as 2 meter. And a half kg object is to be thrown from this point towards the other one. So what is the minimum speed with which it should be thrown so that it can reach the first one? That is the question being asked. Now the point here is that it should have sufficient kinetic energy to reach the point where the gravitational field is going to be 0, because beyond that point the gravitational pull of the smaller sphere will be stronger, so it will pull on its own. So basically we have to locate the point where the gravitational field between the two spheres is 0. Suppose that point is at distance x from the center of the larger sphere. So the equation is then g into 1 kg divided by this distance will become then 10 minus x. So 10 minus x whole square is equal to capital G into 16 divided by x square. If we take square root on both sides, we have 1 by 10 minus x equal to 4 by x, and solving this, we get x is equal to 40 minus 4x, which gives us the value of x as 40 by 5 or 8 meter. So when this distance is 8 meter, at this point the gravitational field is 0. What we will do now is conserve mechanical energy, and at this point we will consider, because the minimum kinetic energy is to be found, so at this point we can consider that the kinetic energy of the particle is going to be 0. If that is the case, then the equation is minus capital G, mass of larger sphere is 16, into mass of the particle by radius is 2 meter. This is the initial gravitational potential energy of the particle with the larger sphere. Then the gravitational potential energy initially with the smaller sphere will be, this will be 1 kg into again mass divided by the distance from the center was 8 meter, right? When it was on the surface of this, the distance from the center of the first one was 8 meter, and whatever its kinetic energy, let's say K, the minimum kinetic energy, this is equal to the gravitational potential energy of the particle with the other two when it reaches at this point, and that value is minus G 16 m divided by, this will now become 8, and minus G 1 into m, this will become 2 meter. So this is the equation. Let's solve for K now. So the value of K, the minimum kinetic energy, well, turns out to be equal to, we can take G small m outside, we have here 8 plus 1 by 8 minus 2 minus 1 by 2. This is again Gm, and if we put the values, let's take 8 as the LCM, it is 64 plus 1 minus 16 and then minus 4. So this is again coming out to be Gm, and the 65 minus 20 is 45 by 8. Quantities, let's say, are in SI units. The value of G, capital G, we can take as 6.67 into 10 to the power minus 11 SI units or Newton meter square per kg square. If we put, and small m is 1 by 2 kg, we put all this, we can see that this value comes out to be close to 1.88 into 10 to the power minus 10 joule. Well, some calculations are required. You need to perform that calculation. The answer is simply 1.88 into 10 power minus 10 joule. So for question 13, option D is correct. Let's go to the next question now. Question 14 says, a point mass m is connected at one end of an ideal spring. Other end of spring is fixed on horizontal smooth surface. Complete arrangement is placed over smooth horizontal plane. Horizontal velocity v0 is given to point mass when spring was in its natural length L0. Find maximum elongation approximately in the spring given L0 is 1 meter, V0 is 1 meter per second, M is 1 kg, K is 1 Newton per meter. This is the diagram that's given. This is the fixed end and mass M is attached here. It's given velocity V0 and we have to find the maximum elongation. Well, as far as concepts are concerned, we can apply conservation of angular momentum about the fixed end because the line of force acting on the particle is passing through the fixed end. So we can apply conservation of angular momentum and we can also apply the conservation of mechanical energy principle. Now suppose the maximum elongation is x. Now that will happen when the particle is reaching somewhere here on this side, and if we apply conservation of angular momentum about the fixed end, well, its value is equal to mv0 L0 initially, and at maximum elongation, let's say speed is v, then it is mv, and elongation is x, then it is L0 plus x. So that means one equation that we have is that v0 L0 is equal to v into L0 plus x. In fact, we can also put the values, and if we put the values, we have 1 is equal to v into 1 plus x. Let's call it equation 1. Of course, there are two unknown now. So let's apply conservation of mechanical energy and that will give us the equation. Initially, the mechanical energy is in the form of kinetic energy of the particle. So we have half mv naught square is equal to, well, at maximum elongation it is speed is v, so it's half mv square plus there is spring potential energy, so half k x square. Let's cancel half on both sides and put the values. If we put the values, we have again on the left hand side m is 1, v naught is 1, so 1 is equal to v square plus x square. And let's equate v square from equations 1 and let's call this equation 2. So v square, we get it as 1 minus x square, and it's also equal to 1 by 1 plus x the whole square. Well, if we further simplify, we get it as 1 minus x into 1 plus x cubed is equal to 1. Well, it's not a quadratic equation. It will not be easy to solve this equation, but we can try by putting the values of x which are given as the option, right? Say for example, if we put option D, that means x equal to 1, it will become 0, so it will not match. D obviously, D equal to 1 does not match. If for example, if we put 0.5 meter, that also does not match. In fact, if we are putting the value of x as 0.839 meter, the equation is satisfied. Okay, so if you start by putting 0.839 meter, we have 1 minus 0.839 into 1.839 cube by, of course, a bit tedious calculation, but after performing the calculation, this is very close to 1. So option A is correct for question 14. Let's go to the next question now. Question 15 says, two thin hemispherical shells of same radius r but different surface mass densities sigma to sigma are joined to form complete spherical shell with center O. Distance of center of mass of this hollow sphere from O is? Well, it's a pretty easy question based on the concept of center of mass, but you have to know the location of center of mass of a thin uniform hemispherical shell. And as a matter of fact, the distance of center of mass of a thin spherical shell from its center of curvature is r by 2 on, of course, this line of symmetry. Here is the center of mass at distance r by 2, where r is the radius of curvature. So this result we'll use here, and it will make the solving of problem very easy. Well, if the upper hemisphere has mass m, the lower hemisphere has mass 2m, because area of the two are equal and the mass is directly proportional to the surface mass density. That means the first shell, hemispherical shell, upper one, we can replace by a point mass here. Let's say it is m, and from O this distance is r by 2. Similarly, the other hemisphere can be replaced by another particle whose mass is 2m, and the distance from O again is r by 2. So now this is reduced to a two particle system whose center of mass is to be found. Since we have to find distance from O, so we can say that distance, if I call it x, then x is equal to 2m r by 2 minus m r by 2 divided by total mass, which is 3m. We see that the m gets cancelled, and what we have is r by 6. So if you look at the options, it is matching with option A. So option A is correct for question 15. Let's go to the next question now.